Another exciting capability of Autodesk Moldflow Insight is that of core deflection analysis. The mold core in this case would be a pin that would make up the center of this part geometry. So in order to see the benefit of doing a core deflection analysis, let's first take a look at the part without doing a core deflection analysis. So here we have a three-dimensional part model with an injection location into the side. If we take a look at the fill patterns, we see that the material comes in from one side, has a slanted flow at first, but then eventually levels out and completely fills the part cavity. So in this case, it looks like the part would have no trouble filling whatsoever. Now if we look at the same component, but now with the mold core modeled in, the mold core we can designate as a particular tool steel. So this one here is set to be P20 tool steel. We have all of the thermal and mechanical properties in there for the tool steel. And we have constraints from one end. So these are 6 degree of freedom constraints from one end, and the other end is free. So again, if we take a look at the flow patterns of the material coming into the cavity, we see the same slanted flow at first, and then eventually the flow still stays slanted to where at the tip it does not complete filling. So we see what is called a short shot at the tip. So see the flow coming up, never straightens out, always slanted, creates a short shot near the tip. There are several ways to show this. The other is an unfilled cavity portion showing that unfilled area. Now again, the reason for this is that the pressurization in the cavity causes this pin to deflect over. So first of all, we'll take a look at the pin moving from its original location over. It doesn't exactly shut off the cavity filling, but it's enough to create hesitation to allow the material to freeze off. The pressure again to do that is created from the filling. So the filling, the pressure is happening on one side of the core and not the same pressure on the other, forcing the core to move over to that one side. So using a simulation such as this, you'd be able to predict a potential manufacturing problem where otherwise you would not.